So we're asked to move this table. We're asked to move it 5 feet to the right and 12 feet up. Let's go ahead. I'll pick red for right and left, or for the right. We'll start from some point. Let's just pick one point, just to have a consistent place to pick from, or to start from. I'm going to go 5 feet to the right. And make that 5 look nice. There we go. And it also goes 12 feet straight up. And the point I want to drive home is I'm going to try to make these vectors here. I'm going to try to make them as proportional as I can to each other. So if this is 5 feet, then I would want to go a little more than twice as long for a 12 foot. Add its arrows, and I call it 12 feet. And the question is, what would be the combined vector here? What would this be? And let's call it vector. Let's just call it vector C. So what would that be? C equals question mark. And before we start on this, let's go ahead and get rid of this crudely drawn vector. But to calculate what vector C will be, first I want to draw a picture of it. I know it's going to go this way, and that crudely drawn one was a bad example because we can find out exactly where it's going to be using our picture. So it doesn't matter, is my point. It doesn't matter if it goes straight up and then to the right, if it goes to the right, then straight up, or if we have two people pushing on at the same time in some random direction and we measured it 12 feet and 5 feet. So my point is, we could say we went 12 feet straight up and then to the right 5 feet. And then that could be how we measure out its vector. So by doing this little tip-to-tip method, basically, where you take one tip and put it on the next one, you can draw a picture of exactly how your vector or your triangle will look at the end. And so this is vector C. And you might have said, well, Mr. Anderson, couldn't we have just, or could we have gone the other way? Could we have gone 5 feet to the right, then 12 feet straight up like it says in the example? And the answer is yes. If you were to redraw it there, it would end in the exact same place. Because math. So we can figure out both the magnitude and the direction with this information. By looking at this picture, we can figure out the magnitude using a squared plus b squared equals c squared. And we can figure out the direction, which is up and to the right, by the way. So it's going up and to the right. That's the sense. But we can figure out the direction by using, well, if you look, we have an angle here. That's going to be our direction. Well, that's going to be, we're using opposite and adjacent. So that's tangent. We could use SOHCAHTOA. And opposite and adjacent is tangent. So we'd use the inverse tangent to find the magnitude and the direction that make up this vector, which add up to the vector. That's all a vector is magnitude and direction. So let's start with the angle. Let's find that first. So it's opposite over adjacent. So that's inverse tangent of, well, opposite to the angle is 5 feet and the adjacent is 12. So just 5 over 12. And to figure out what that is, we just pull out our handy dandy calculator and we go to our inverse tangent, which is above tangent. So we hit second tangent and then just 5 over 12. And we get an angle of, what, 22.6 degrees? So this is 22.6 degrees, and it's up and to the right, or we could say it's coming clockwise. It's coming clockwise from the positive y-axis. And then from there, we can go ahead and solve for our magnitude as well. It's a squared plus b squared equals c squared. Well, a squared is just 5 feet, so 5 squared plus b squared is 12 feet, so plus 12 squared equals c squared, which in our case just happens to be vector c squared. Well, 5 squared is just, what, 25? 25, and we could say 12 squared is 144, and we could set that equal to whatever c squared is. Well, 25 plus 144 is just, what, 169? And then I don't know what the square root of that is, so we could just type it in our handy-dandy calculator. We could say the square root of 169. And feel free to go back and check my math if you want to. But it equals 13, so vector C, the magnitude, is 13 feet. So from there, let's go ahead and try a more difficult example. Let's say we have another table, just a random table. And let's say it was pushed upward 12 feet. So we go all the way up 12 feet. And let's say it was pushed to the right just 9 feet, so I'll make that a little bit shorter than that one. And let's say it's also pushed downward 7 feet. I'll make this one even a little bit shorter than that one. And just for fun, let's go ahead and add one more. Let's say it also was pushed to the right again 2 feet. So my question for you is, what is the final vector? So to figure this out, I'm going to just sort of draw a picture of it to kind of get an idea. So I'm going to start at some random point again. Let's say, let me get my pencil out. Let's say we start right here. And first we go, and it doesn't matter which one you start with, by the way, but we'll just say first. First we go 12 feet straight up. So we go 12 feet straight up. 12 feet. And then we go 9 feet to the right. 9 feet. And then we go 7 feet straight down. So we'll make it a little bit more than half of that 12 feet. So 7 feet. From there it goes 2 feet to the right. So the question is, what is the final vector? Well, it's going to be just equal to basically this line and its angle. And we'll call this vector vector D. Well, to figure out what vector D is, we'd need our x and y components. So we'd need our x component. D of x is what we'll call it. So D of x. And the y component, which we can just call, and you might be sensing the pattern here, D of y, and I just call it that because it makes sense. The y component of D. And you might ask, well, how are we going to figure out this, Mr. Anderson? How are we going to figure out what these two are? Well, to be honest, they are as simple as you might think it would be. To find out what the total x value is, D of x, we would just have to add up all of our x values. And to find out the total y value, we would just have to find or add up all of our y values. So I can even write this out. I could say, well, D of x equals the sum of all x values. And I'll make a little note off to the side that this symbol, this little weird sideways M thing, means sum of all. Well, our x values just are, what, 9 and 2? So it's 9 feet. 9 and 2. Blue is what I used for that. Now, the question is, are they positive and negative? Well, they're going to the right, which makes them vectors, which makes them both positive. So it's just 9 plus 2 equals a total x value of 11 feet. And then D of y would be the exact same thing. D of y would equal the sum of all y values, which is just, what is it? What, 12 and 7? So we have 12, and then I chose 7 in this color. But notice that 12 is going up, which makes 12 a positive value. And 7 is a vector going down, which makes 7 a negative value. So it's basically just 12 minus 7, which is 5. And it's in total going up from its original amount, so it's positive 5. So equals positive 5. And we can also put in that this 11 feet was also positive. It was positive down here too. And that just tells you the direction or the sense. That's the whole point. It tells you that it's going up and to the right. That's what positive x and positive y mean. Positive x is to the right and positive y is up. So from there we can find the direction by using SOHCAHTOA. So in this case we have the opposite and the adjacent. So it's going to be inverse tangent of opposite over adjacent, which is 5 over 11. So we type that in our handy dandy calculator. So we take inverse tangent of 5 over 11. And we get an angle of, or a direction of, 24.4 degrees. And that's up and to the right. Or you could say that it's counterclockwise from the positive x-axis. Either's correct. But if you say degrees, you need to say really which axis you're coming off of. So 24.4 from the x-axis. And oops, I forgot to write x. But from there we can find the magnitude as well, and that's just a squared plus b squared equals c squared again. Well, a squared is 11 and b squared is 5, so it's 11 squared plus 5 squared equals whatever d squared is in this case. Vector d squared. So we find this out by typing in our calculator. We say, 11 squared plus 5 squared. And what do we get? 146. And so we take the square root of that, the square root of 146. And it should be a little bit bigger than 12. We got to convert it, and we get, 12.1. So equals 12.1 feet. And so now we have the magnitude and the direction of our final vector using these 4 individual vectors, combining them.